Okay, now that we've gotten through the identities and the definitions, we are going to move on to differentiation of hyperbolic functions. We are not going to be looking into the integration of hyperbolic functions. Okay. And here are some more derivatives and integrals that you need to write down. Actually, you don't need to necessarily worry about the integrals, but you do need to worry about the derivatives. And some of them kind of make sense. We know that the derivative of sine of x would be cosine of x. So the derivative of the hyperbolic sine function of u would be the hyperbolic cosine function of u, and then times ru prime. This is something that we've seen in a lot of the patterns and the derivatives that we've done where we've had to multiply by u prime because of the chain rule. Cosine's hyperbolic function's derivative is just sine, so we don't have to worry about the negative sign here. Tangent is going to be the hyperbolic secant function square root of u times u prime, and then so on and so forth. You can go through all of those and go ahead and copy down all of these derivatives. Okay, I really want to get into some examples for you so that you have an idea of how we can apply all of these formulas that we've been giving you. So in example A, we're going to take the derivative of the hyperbolic sine function of x squared minus 3. And if you recall from the sheet right here, we know that the derivative of the hyperbolic sine function of u is just the hyperbolic cosine function of u times u prime. So that formula is exactly what I'm going to do right here. Okay, so hyperbolic sine function ends up being the cosine hyperbolic function. We write the expression, which is our u right here, and then times our u prime. So the derivative of x squared minus 3 is 2x. So there is our u prime right there. So this is our answer, 2x hyperbolic cosine of function x squared minus 3. The next example, I want you to understand that we can go ahead and apply all of our differentiation rules that we have. So we know how to take the derivative of the natural log of x or the natural log of u. And in this example, our u ends up being a hyperbolic function. So the derivative of the natural log of x, remember, is just 1 over x. If it's a u, okay, then the derivative is going to be 1 over u times u's prime. Okay. So in this case, this is our u. So it's going to be 1 over u. Here's our u and here's our du. We know that the derivative of cosine's hyperbolic function is sine's hyperbolic function. So what we end up doing is we say 1 over the cosine hyperbolic function, and then we have to multiply by u's prime, so the derivative of u, which ends up being the sine's hyperbolic function. So we really end up getting the sine hyperbolic function over the cosine hyperbolic function, which ends up equaling the tangent's hyperbolic function. Okay, so this actually ends up being our answer on this example. Letter C. As you can see, we have x times the sine's hyperbolic function of x minus the cosine's hyperbolic function of x. So in this case right here, we're going to have to use a product rule. So we will write the first, okay, which is our x right here, times the derivative of the second. So the derivative of the sine's hyperbolic function of x is going to be cosine's hyperbolic function of x, plus the second, okay, which is our sine hyperbolic of x, times the derivative of the first. Well, derivative of the first is just 1. Okay, so times 1. So far, this is all that I've done right here. Then I'm going to subtract the derivative of cosine's hyperbolic function, which just ends up being sine's hyperbolic function. And then as you can see, plus sine hyperbolic function minus sine hyperbolic function, that ends up dropping out, and we're just left with x times cosine of hx, so on and so forth. This last example that I want to do for you is we are going to find the relative extrema of f of x is equal to x minus 1 times the cosine's hyperbolic function of x minus sine's hyperbolic function of x. So if you recall, finding the relative extrema just means that we're trying to find the critical points. What are our possible minimum and maximums? And so the first thing that we need to do is we need to take the derivative. So I'm going to take the derivative of this function, and as you can see, x minus 1 is going to be one term, cosine's hyperbolic function of x is another term. So we're going to have to use a product rule when we go ahead and take this derivative. So here's our derivative. We get the first times the derivative of the second, which is sine's hyperbolic function, plus the second times the derivative of the first. Well, derivative of the first is 1. And then we have to subtract the derivative of the sine's hyperbolic function, which is the cosine's hyperbolic function. Okay, and then we end up getting this canceling right here and here, and we're basically left with x minus 1 times sine's hyperbolic function. Now, recall when we're finding the relative extrema, after you take the derivative, you need to set it equal to 0. And then we're going to set each one of these terms equal to 0. So we're going to set x minus 1 equal to 0, and we're going to set sine's hyperbolic function of x equal to 0. Okay? This one's pretty easy to solve. We end up getting x is equal to 1, so that is one of our possible critical points, critical values. And here, in order for us to find what x is, so that this derivative is equal to 0, we need to use the definition of sine's hyperbolic function. And that is e to the x minus e to the negative x over 2. So that's one of those definitions that you wrote down initially in this section. I can multiply both sides by 2. And now my 2's are gone, and I'm left with my numerator. E to the x minus e to the negative x is equal to 0. 0 times 2 is 0. And then, because this part right here is negative, I'm going to move that over to the other side. So I'm going to have e to the x is equal to, and then I'm going to move this e to the negative x over here, only I'm going to put the e to the negative x in terms of having a positive exponent. So far, all I've done is I've taken this term right here, and I've moved it over to this side. Okay. Then in order to solve, I recognize that if I multiply this side by e to the x, this goes to 1. If I multiply this side by e to the x, I end up getting e to the 2x is equal to 1. And then it's just a matter of, okay, what does x have to be so that e to that number gives me 1? Well, x has to be 0. So these two are our two critical points. And our last step is to figure out what our y component is for these ordered pair, because we do want to name them as an actual point. Okay, so let's start with x equals 1. So when x is equal to 1, we're going to take 1 and we're going to substitute it into our original function. Okay, so this function up here. So we're going to end up getting 1 minus 1 times cosine's hyperbolic function minus sine's hyperbolic function of 1. And I know that 1 minus 1 is 0, so this whole piece right here is going to 0, and that's going to be gone, and I'm going to be left with the negative sine's hyperbolic function of 1. You can, when you go to put this in your calculator, you can exchange this for the definition of the sine's hyperbolic function, and then just go ahead and substitute 1 in for x. So you'll have that e to the x minus e to the negative x over 2. You'll take that definition, take the opposite of it, and then substitute 1 in for x. Another thing is I believe that the iPhones, if you turn your iPhone on the side, it does have sine of h. It does have hyperbolic functions. You can also, if you want to get a decimal form of this, you could do that as well. The way I wrote this ordered pair was just 1, comma, and then this is what we ended up getting is the negative sine's hyperbolic function of 1. Whoops, that's supposed to have a 1 in there. Okay. And then let's do the same thing for x is equal to 0. So now I'm going to plug 0 in for my original function. 0 minus 1 is a negative 1. Cosine's hyperbolic function of 0, and then minus sine's hyperbolic function of 0. This one you can put in your calculator and you actually get 0 for that, so that's going to disappear, and we're going to be left with a negative cosine's hyperbolic function of 0, and you can substitute that in and you end up getting negative 1. Again, you can put that in your calculator, or you can put in your e to the x plus e to the negative x over 2 definition into here. Just take the opposite and then put 0 in for your x value. So in this case, when we substituted 0 in, we got negative 1. So our other possible extrema is at the point 0, negative 1. That concludes this lesson. Hope you guys had a great day.